Golden Iris Production presents an electromagnetic vacuum construction of the gravitational constant, Deriving Emergent Gravity, by Mark F. Dennis. Abstract. This work presents a step-by-step electromagnetic vacuum construction that numerically reproduces the Newtonian gravitational constant, g. Beginning with Coulomb's constant, we follow a prescribed algebraic sequence involving electromagnetic constants, the Planck length, and the fine structure constant. This sequence ultimately yields the standard expression for g in terms of Planck units. G equals the Planck length squared times c cubed divided by h bar. Introduction. The gravitational constant g appears in both Newtonian gravity and Einstein's field equations. Meanwhile, the electromagnetic vacuum constants epsilon naught, mu naught, the elementary charge, and the speed of light are tightly linked through Maxwell's theory. The Planck length connects gravity with quantum mechanics, tying together h bar, g, and c. In this presentation, we follow a structured algebraic path that begins with Coulomb's constant and ends with the Planck scale expression for g. Starting with Coulomb's law. Coulomb's law describes the electrostatic force between two charges. Its inverse square form mirrors Newton's law of universal gravitation. Both laws share the same mathematical structure, differing only in their coupling constants. This parallel motivates the search for a deeper connection between electromagnetism and gravity.
Step 1. Coulomb's constant. We begin with Coulomb's constant K, defined as 1 over 4 pi epsilon naught. This value serves as the algebraic starting point for the construction. Step 2. Multiply by 4 pi epsilon naught. Next, we invert the constant 4 pi epsilon naught. This produces a very large value, setting the stage for the scaling that follows. Step 3. Divide by the charge squared. We now introduce the elementary charge and set the distance term to 1 square meter. Dividing by the charge squared produces a dramatic amplification, reflecting how small the electron charge is. Step 4. Maxwell identity. We bring in the speed of light through Maxwell's identity, c squared equals 1 over epsilon naught times mu naught. This substitution introduces relativistic scaling into the expression. Step 5. Alternate electromagnetic form. Multiplying both sides by c to the fourth power moves c squared into the numerator. This step shifts the expression into a form dominated by electromagnetic vacuum constants. Step 6. Vacuum-only form. We convert c squared back into epsilon naught and mu naught. The expression now depends solely on vacuum constants and the elementary charge. Step 7. Introduce the Planck area. By multiplying by the Planck length squared, we scale the enormous electromagnetic values down to the Planck domain. This step bridges the electromagnetic vacuum with quantum gravitational geometry. Step 8. Fine structure constant. Finally, we multiply by the fine structure constant alpha. This yields the numerical value of the gravitational constant, g equals 6.67 times 10 to the minus 11. We have now derived g directly from Coulomb's law and vacuum constants.
Final identity. Using the definition of the fine structure constant, we rewrite the expression for g in a purely vacuum-based form. Substituting Maxwell's identity once more, we recover the standard Planck scale expression. G equals the Planck length squared times c cubed divided by h. This closes the loop, showing that the Planck length itself is defined by h, g, and c. Conclusion. Beginning with Coulomb's law and the electron charge, we systematically incorporated the vacuum constants epsilon naught, mu naught, and the speed of light. Through this algebraic sequence, we established a numerical bridge from electromagnetism to gravitational phenomena. Introducing the Planck length squared allowed us to scale enormous electromagnetic values down to familiar units, linking quantum physics with macroscopic gravity. Conclusion continued. Multiplying by the fine structure constant allowed us to recover the gravitational constant numerically. This demonstrates that Newton's gravitational constant can emerge from Coulomb's law when combined with vacuum and Planck scale physics. The result highlights the deep interplay between electromagnetism, quantum mechanics, and gravity. Conclusion continued. By tracing the chain from Coulomb's law through vacuum constants, the speed of light, Planck geometry and the fine structure constant, we have shown that G emerges naturally from electromagnetic principles. The same inverse square structure that governs electrostatics can reproduce the strength of gravity when scaled through the vacuum and the Planck domain. This suggests a deeper unity among the fundamental forces. Conclusion: a eureka moment. With this understanding, we may one day be able to engineer gravity, manipulate inertial effects, or unlock new technologies. The realization that G can be derived from electromagnetic and vacuum constants reshapes our view of gravitational phenomena. To be continued.